Coming up next, Mercy. Even though it might seem harmless, this little white box is capable of traversing all kind of terrain thanks to its 4 Daguwal thumper wheels, revolved by 4 12 DC motors. It is fast, it is agile, and it is strong. It can even carry your laptop.
Essentially, Mercy is a mobile robot that dreams of becoming a personal assistant for elderly people. To do so, it will have to become fully automated and new mechanical parts need to be added to its current design. However, as of yet, it is perfectly controllable via radio frequency controller.
She was designed thinking of elderly people because we consider that taking care of the ones who took care of us when we were kids is about the noblest thing we can do with our techie knowledge. Furthermore, it is important to recognize that as age goes by, a human's physical and mental capabilities tend to decrease, for which is imperative to safeguard elders from daily risks.
Mercy's structure is simple. Its outside shell is a rectangular wooden box that helps keep and protect its circuits. On its top, the little black device that can be seen is a LiDAR. Mercy hasn't learned to use it yet, but it is intended to serve as her eyes, for its laser will help her detect obstacles, measure distances, and create maps.
The rear part has 2 switches and a 3.15 ampere fuse to protect the robot from discharges. The yellow switch is the main on-off button, while the red one only affects the motors. Nonetheless, both switches must be on for Mercy to be able to move around. Notice that a small LED below each switch will shine bright when it's on.
Mercy's face currently has nothing but a hole. During this first stage, this serves no purpose, but later on, it will become a water and pills dispenser. Finally, Mercy's bottom has nothing but her 4 wheels and DC motors.
Right now, Mercy inside are composed only by its circuitry, but soon enough, a water tank, a rotating pie-shaped pill selector, and a dispensing mechanism will join the show.
In a nutshell, Mercy's circuit is made up of an Arduino, a couple of batteries, one for the motors and one for the Arduino, and 2 motor drivers to give speed and direction to each pair of motors. Currently, the Arduino board is Mercy's brain. It receives the signal from the RF controller and converts them into a PWM and digital signals to control the drivers. A Raspberry Pi 3 can be observed attached to one of the sides. This will allow Mercy to connect to the local network and to get information from a PC and the LiDAR, which will help her navigate.
Mercy's controllability is simple. There are 4 main commands that even a kid can memorize to be able to take Mercy anywhere. To move to the front and back, simply move the controller's left stick in the desired direction. Keep in mind that this stick also controls speed, for which the more the stick is pushed in either direction, the faster Mercy will go.
To make Mercy turn, give her some front speed with the left stick while moving the right stick either to the left or to the right. Make sure to push them all the way and remain pressing them until you want Mercy to stop turning. This project represents the closure of her professional studies. I am happy to realize how fast and neatly we are now capable of developing something like this. Even though right now Mercy is a simple remote control car like the ones kids play with, in no time it will become a real engineering product that will help as the basis of something that could change people's lives.
This project is a challenge. Being able to develop a full project utilizing the knowledge we have acquired through the career is not something that should be considered easy. But we fully trust in our capabilities of creating a project that can innovate and create a true utility for the elderly people.
Up to this point, Mercy may look pretty and simple, but in no time, and with the help of our knowledge, it will become a useful robot assistant for elderly people to improve their quality of life.
As a result of this partial presentation, we can have the base for the future. It was a hard work, but the final result was excellent. From now on, we can focus on the functionality that we are going to develop in ROS for the autonomous part.
Overall, the results obtained for the first delivery are excellent. Since we managed to organize and equally distribute work, we were able to finish the basic functions and even some minor features. Not everything was perfect, but I think in the end, Mercy worked and looked as expected. I am more than pleased with our team and with the outcome.